All right, we are going to talk about work and power. So work is done when force causes an object to move. That's basically what we're trying to understand when we talk about work. So by the end of this, you should be able to define work and describe the relationship between energy and work, as well as calculate work and power. So work is the transfer of energy that occurs when a force makes an object move. So anytime a force actually makes an object move, work has been done because energy has been transferred from the force to the object to make it move. So for work to be done, something has to move. That is definitely a requirement. And the motion must be in the same direction as the force. So this isn't one of those things where we were talking about an equal and opposite reaction necessarily. But like if you push a rolly chair forward, the rolly chair should go forward. It shouldn't go backwards. That would be confusing. But that means that work has been done. You have transferred the energy from your arms into the chair, and the chair has moved, and the chair is moving in the same object that I applied the force for it to move. So that means work has been done. When work is done, a transfer of energy always occurs. So I have transferred energy from myself into that chair. So if you apply a force without causing an object to move, have you done any work? You need to think about that. If you remember some of the criteria, something has to move. Well, if it doesn't move, is work done? And the answer to that is no. It has to move, and it has to be in the same direction as the force that's been applied. So work and energy. If you carry a box up some stairs, you're doing work, but you're also transferring energy to the box. As the box's distance from the Earth's surface changes, so does the gravitational potential energy. Remember that that's the chance that that object will fall to the Earth, or the amount of energy that it would fall to the Earth creating. So when you calculate work, work is calculated in a unit called joules, which we'll talk about in a sec, but we are looking to calculate work in joules using the force in newtons. Remember, we calculated force equals mass times acceleration, and distance in meters, how far away the force is moving it in meters, and that is what you use to calculate the work. So here's an example. You push a wheelbarrow with 100 newtons of force. You move that wheelbarrow 5 meters. How much work did you do? Well, we have a force and we have a distance, so we can put the force here, the distance here, so that means our work is 500 J, and remember J stands for joules. So I want you to pause this. There's a couple of practice problems right here. A force of 75 newtons is exerted on a 45 kilogram sofa, and the sofa is moved 5 meters. How much work is done moving the sofa? So that's your first one. And a lawnmower is pushed with a force of 80 newtons. If 12,000 joules of work is done in mowing a lawn, what is the total distance in meters the lawnmower was pushed? So those are the two you need to do. Do me a favor and make a square around your answers. Make sure to use your units because that's what I will be looking for. So work, work. So we do 75 newtons times 5 meters is going to equal 375 joules. And 12,000 joules is going to equal 80 newtons times the distance. We don't know the distance, so the distance is going to be 150 meters. Power. So we know how to calculate work now, so let's look at power. Power is the rate at which work is done, so how quickly is that work done? So now we're looking at time. So power takes into consideration how much work is done, so if you calculate work using the previous equation, whatever work you get, so however much work is done on an object and how quickly that work was done. So power is measured in watts, or a W if you're just using for or looking for the unit. Power is measured in watts, and so we look at the work and we divide it by the amount of time it took to do that work. So P equals W divided by T, so that is power. So to lift a baby from a crib, 50 joules of work is done. How much power is required to lift the baby in 0.5 seconds? So we know our work, we know our time, so all we would need to do is divide those two. The power would equal 100 watts. All right, so I hope that made sense. You're going to have to do these calculations in class tomorrow, so if you have a calculator, make sure you bring it with you. And yeah, I hope that makes sense, and I will see you tomorrow.